Dr. Bharti Patil, working as an Assistant Professor Physics in the Department of Physics, Maharaja Jivajirao Shinde College, Srigonda. We have started our syllabus related to solid state physics, and we have started first chapter of it, the crystalline state. During our last lecture, we have calculated that the reciprocal of reciprocal lattice is direct lattice. It means that we have seen one of the property of reciprocal lattice. That is, suppose A is a translational vector in direct lattice, then reciprocal of A will be represented as A star, and its reciprocal is, again you have to place A star, and its value will come out as A. That is, the reciprocal of a reciprocal lattice is nothing but a direct lattice. That we have covered during our last lecture. During our today's lecture, we will try to finish the point related to reciprocal of a BCC, that is body centered cubic lattice, is FCC lattice, or FCC lattice is the reciprocal of body centered cubic lattice. In order to prove that the reciprocal of body centered cubic lattice is face centered lattice, one has to consider three body centered unit cells as shown in figure, which are present in a body centered cubic lattice. As we are dealing with a cubic system, unit cell will have edge A, that is, all primitive lanes will be A and A. Then, as this is a body centered cubic lattice, therefore each unit cell will have three crystallographic axes X, Y, Z. Then there are 8 corner atoms and one extra atom which is located at the center of each unit cell, and each of these unit cell will have its translational vectors along X, Y and Z axis. Now we have to consider these unit cells which are located inside the lattice and forming a body centered cubic lattice. In order to prove that the reciprocal of body centered cubic lattice is face centered lattice, one has to consider a origin which is located at the intersection of these three unit cells as shown in figure 1.51. It is denoted with O. Then draw three axes as shown in figure, that is X, Y and Z. Then they are along the lengths of the unit cells. Now, as we want to find the reciprocal of BCC lattice, one has to represent the primitive translational vectors of body centered cubic lattice, and they are considered as A dash, B dash and C dash along X, Y and Z axis. Now, how to obtain A dash? A dash will be obtained by joining origin to a body centered atom. Then B dash is a translational vector. It is obtained by joining origin with a body centered atom along y-axis, and it is along y-axis, and C dash is a translational vector which is along z-axis, and it is obtained by joining origin to body centered atom as shown in figure. Now we want to find the value of A dash, B dash and C dash. In order to find value of A dash, B dash and C dash, consider orthogonal unit vectors which are parallel to cubic edge along this direction as x cap, y cap and z cap. One can use instead of x cap as I cap, instead of y cap as z cap and instead of z cap as z cap. K cap, I, J, K instead of X, Y, Z. In few books they have preferred to use I, J, K, and the book which we are having, in that book they have used X, Y, Z notations. Therefore I have followed the same here. Now what we have considered up till now, we have taken three body centered unit cells. Then we have considered a origin which is situated at the intersection of them. Then we have drawn XYZ axis. Then we know that A is the lattice parameter or the cube edge. Then we want to find A dash, B dash, C dash, which are nothing but the translational vectors along x, y, z axis, and their value can be obtained by considering that in case of A dash, the point A dash is situated at a distance a by 2 from x-axis, positive x-axis, then the same point can be reached from y-axis at a distance of a by 2 from y-axis, and in order to reach that point one has to travel minus a by 2 distance along z-axis, because this point is located in xy plane. So A dash is given as a by 2 x plus a by 2 y cap minus a by 2 z cap. We will take a by 2 as a common and it will give us primitive translational vector A dash as a by 2 into bracket x cap plus y cap minus z cap, where x, y, z are orthogonal unit vectors parallel to the cube edge. Same will be the case of B dash. In order to reach that point which is located at the body center position in YZ plane, one has to travel minus of a by 2 distance along x-axis, then a by 2 distance along y-axis and a by 2 distance along z-axis. Because our length is a, cube edge is a, and this body centered atom is at the center. Therefore, in each case, the distance which is travelled from origin comes out as a by 2. Hence, by similar way, one can find out A dash is equal to minus of a by 2 x cap plus a by 2 y cap plus a by 2 z cap. Taking a by 2 common, you will obtain B dash value as a by 2 into minus of x cap plus y cap plus z cap. Then we will obtain the value of C dash, that is primitive translational vector along z axis. In order to obtain its value, we have to move a by 2 distance along x axis minus a by 2 distance along y-axis, because this point is located in xz plane, and plus a by 2 distance in z-axis. Therefore, c cap will become a by 2 into x cap minus a by 2 into y cap plus a by 2 into z cap. Taking a by 2 common, you will get final value of c dash as a by 2 into bracket x cap minus y cap plus z cap. So this basic information you have to write at initial stage in order to explain the reciprocal of BCC lattice is FCC lattice. Now we know that volume of primitive unit cell is given by volume V is equal to A dot B cross C. Just now we have calculated the values of A, B, A dash, B dash and C dash. Here V is equal to A dash dot B dash cross C dash. So substituting value of B and C, you can obtain B cross C. What is the B cross C value? B cross C value becomes a by 2 into a by 2, that is a square by 4 into bracket minus x cap plus y cap plus z cap cross x cap minus y cap plus z cap. Now we will solve this equation by using matrix as shown in figure. Therefore, solving this you will obtain a square by 4 into bracket x cap into bracket 1 plus 1 minus y by multiplying minus 1 into 1 comes out as minus 1, minus 1 into 1 comes out as minus 1, that is minus y cap into bracket minus 1 bracket complete plus z cap into bracket product of minus 1 into minus 1 comes out as plus 1 minus product of 1 into 1, that is 1. We know that 1 minus 1 is equal to 0, therefore z term vanished. So a square by 4 into bracket twice of x plus twice of y. Taking 2 common, you will get a square by 4 into 2 into x cap plus y cap. So dividing 4 by 2, you will get a square by 2 into x cap plus y cap. This is the value of B dash cross C dash. Now again moving towards the volume. Volume is nothing but A dash dot B dash cross C dash. So we know the value of A, that is primitive translational vector A. Here its value is a by 2 into x cap plus y cap minus z cap into, just now we have found out the value of B cross C. Its value is a square by 2 into x cap plus y cap. So solving this you will obtain V is equal to a cube by 4 into 2, because we know that x cap into x cap is equal to 1 and y cap into y cap is equal to 1. X cap into y cap is equal to 0. X cap dot z cap is also equal to 0. Therefore, this equation gives us a by 2 into x cap as 1 plus y cap into y cap as 1. 1 plus 1, 2. 2 so v equals to a into a square comes out as a cube, and here 2 is in numerator and 4 2 into numerator, 2 into 2 denominator, 2 into 2 becomes 4. A cube by 4. Initially we wrote a cube by 4 into value of x dot x1, value of y dot y1, 1 plus 1, 2. So 2 ones are 2, 2 twos are 4. Therefore volume comes out as a cube by 2. Now we will move towards the reciprocal lattice vector. We know that the reciprocal lattice vector A is given as B dash cross C dash divided by A dash dot B dash cross C dash. B vector is given as C dash cross A dash divided by A dash dot B dash cross C dash, and C dash vector is given as A dash cross B dash divided by A dash dot B dash cross C dash. So considering first vector along x-axis, A is equal to B dash cross C dash divided by A dash dot B dash cross C dash. Just now we have found out the value of B dash cross C dash. Its value is a square by 2 into x plus y, x cap plus y cap. And just now we have also calculated the value of volume as a cube by 2. Substituting these two values in A, we will obtain the reciprocal lattice vector A is equal to a square by 2 into x cap plus y cap divided by a cube by 2. So solving this, we will obtain the value of A is equal to 1 upon small a into x cap plus y cap. Similarly, one can obtain the value of b cap as 1 upon a into y cap plus z cap, and c as vector c as 1 upon a into z cap plus x cap, where capital A, B and C, these are the reciprocal lattice vectors, and hence these vectors are primitive vectors of FCC lattice. These values, if we observe, these values are nothing but the primitive vectors of FCC lattice. Hence, one can say that FCC lattice is the reciprocal of BCC lattice. FCC lattice is a reciprocal of BCC lattice. So, once again we will recall the session, that is, we have considered the three body-centered unit cells, and we have placed the atoms at the center of each unit cell. We have connected these 3 points from our origin, and we have expressed A dash, B dash, C dash as a primitive translational vectors of a body-centered cubic lattice. We have defined small a as a length of unit cell, and in order to explain the value of a dash, b dash and c dash along x, y, z direction, we have considered x cap, y cap and z cap as orthogonal unit vectors parallel to the cube edge. Then we know the value of volume. Volume is equal to A dot B cross C. We have first of all found out the value of B cross C. Then we have found out the value of V. Then value of B cross C comes out as A square by 2 into x cap plus y cap. Value of V comes out as A cube by 2. Then we know that the reciprocal lattice vectors capital A, capital B, capital C are given as capital A dash, capital B dash, capital C dash are given as B dash cross C dash upon A dash dot B dash cross C dash. Then substituting the value of B cross C and volume, one can obtain the value of A, and A comes out as 1 by A into x cap plus y cap. B comes out as 1 upon A y cap plus z cap, and C comes out as 1 upon A z cap plus x cap. But if we look at these vectors, then these are the primitive vectors of FCC lattice, and hence one can say that FCC lattice is the reciprocal of BCC lattice. Thank you.